In this video, we're going to solve quadratic equations by finding the square root. So remember, in a quadratic equation, you always have the x squared term. Okay, we're going to use the square root property. If x squared equals some number n, then x equals plus or minus the square root of n. Because if we square a number, we don't know if that number was originally positive or negative. Because a negative times a negative is a positive, and a positive times a positive is still a positive. So we have to take into account if it was originally positive or negative. So when you have the plus or minus, it means that this value could be both positive and negative. So both are taken into account. So we're going to solve some equations for x. So you still draw the line down through the equal sign, because anything you do to one side, you must do to the other. We want to get x all by itself. Currently, x is squared. Opposite of squaring something is taking the square root. They undo each other because they're opposites. So to get x by itself, I'm going to take the square root of both sides. So square root of x squared is just x. And over here we have the square root of negative 36. All right, well, we can't take the square root of a negative. So let's do the square root of negative 1 times 36 under the square root sign. So we know the square root of negative 1 is just I, the imaginary number. Well, we know the square root of 36 is 6, because remember, square root means what number times itself equals the number under the square root sign, and 6 times 6 is 36. So I can rewrite this as square root of negative 1 times 6 times 6. Number times itself, it can come out, and the square root of negative 1 is I. So this is x equals, and because we took the square root, I forgot to put that plus or minus in front of it. Positive or negative, square root of negative 1 is I, and square root of 36, 6 times 6. So we have plus or minus 6i. That's what x is equal to. Okay, so over here, we're going to do the same thing. We're going to solve for x. First step, though, is we have 2 multiplied by x squared. We know that we're going to have to take the square root of x squared, but before we do that, we want to get x squared all by itself. Move everything else to the other side of the equal sign. Because x squared is being multiplied by 2, we're going to divide both sides by 2. So we're left with x squared equals negative 50 divided by 2 is negative 25. Okay, now that x squared is all by itself, we can take the square root of both sides. Square root of x squared is just x equals. But again, we have to take it into account if this was positive or negative. So plus or minus. Right, this is the same thing as before. I can't take the square root of a negative. So I'm going to factor this out. So negative 1 times 25 gives me negative 25. So I'm just moving that out because I know the square root of negative 1 is I. 25 breaks down to 5 times 5. Okay, so I'm going to say x equals plus or minus. Square root of negative 1 is I, and because 5 is buddied up, it can come out. So I have x equals plus or minus 5i as my answer. All right, and so now we're going to get just a little more complicated. We're going to zoom in. All right, in this one, I have 4x squared plus 1 equals negative 17. So I have x squared being multiplied by 4, and we have 1 being added on. Remember, I said you have to get x squared all by itself before you can take the square root of both sides. So I'm going to start by moving this plus 1 to the other side by subtracting 1 from both sides. 1 minus 1 is 0, so we have 4x squared equals negative 17 minus 1 is negative 18. Now here I need to divide both sides by 4. 4 divided by 4 is 1, so I have x squared equals negative 18 over 4. I'm not going to reduce because I know that 4 in the denominator, well, I know that the square root of 4 is 2. So if I take the square root, that's a perfect square, so I don't want to reduce. So at this point, I'm going to take the square root of both sides because x squared is by itself. I'm going to write x is equal to plus or minus. Remember when you're taking the square root, if you have a fraction, you're going to take the square root of the top, square root of negative 18, over square root of bottom, so square root of 4. So you're going to break it up and you're going to do the square root of each of those individually. You cannot have a square root in the denominator, but we're going to be okay. I'm going to bring this up and rewrite it. I have x equals plus or minus square root of negative 18. I'm going to break this down. I want to have negative 1 times. I like to do a factor tree and break it down to its prime factors. Well, 18 is 9 times 2. 2 is prime. And 9 is 3 times 3. Those are all prime. So I'm going to write that under here. We have 3 times 3 times 2. And I like to, if they have buddies, I like to put them together. All right, so I know if I take this square root of negative 1 out, that gives me an I. I have a 3 times 3. They're buddied up, so I can bring a 3 out also. 2 stuck at home underneath that square root sign, though. All right, I'm not done. Because this is over, it's a fraction, over the square root of 4, which square root of 4 is 2 times 2. So I know on the denominator, I can bring a 2 out. All right, so we have x equals plus or minus. Okay, on top I was able to bring out a 3 and an I. So 3i, 2 stuck under there, square root's of 2, because it didn't have anybody to buddy up with, so it stays under the square root sign, over 2. So this entire fraction is plus or minus 3i, square root's of 2, over 2. And that is my answer. All right. I have another example. I'm just going to draw a line here so you can see where my problem's separated. All right, I have an x minus 1 inside parentheses that are squared. So because that entire part is squared, that's what I want to get on one side of the equal sign all by itself. That times 3 has to go away. So I'm going to divide both sides by 3. That's my first step. 3 divided by 3 is 1. So I'm left with x minus 1 squared equals 75 divided by 3 is 25. All right, at this point, I have my value squared all by itself. Yes, there's something inside that parenthesis, but the whole parenthesis itself is squared. So I'm going to take the square root of both sides. All right, so we have square root of x minus 1 squared. That square root and the squared undo each other. So I'm left with just x minus 1 equals square root of 25 is 5. But it has to be plus or minus 5 because we took the square root of both sides. All right, but that means I need to solve this. So I have two problems that I'm solving. I'm solving x minus 1 equals positive 5, and I'm solving x minus 1 equals negative 5. I'm splitting it up so I can actually solve. Here I'm going to add 1 to both sides, and x is equal to 6. So that's one of my answers. Here add 1 to both sides, and x is equal to negative 4. Okay, in this case, I did not have the imaginary number I because I didn't take the square root of a negative. So pay attention to that. It's only if you take the square root of a negative that you'll have that imaginary number. Here I was actually able to solve for true values because there wasn't an I. There wasn't an imaginary number. All right. I'm going to have you try 4 problems. Go ahead, try to solve them. Come back and I'll go through the answers with you. All right, so this first one, I'm going to subtract 15 from both sides. So I get x squared equals negative 49. When we take the square root of both sides, we get x equals positive or negative. Hopefully you didn't forget that. And 7 times 7 is 49. And the square root of the negative 1 is I. So x equals plus or minus 7i. Okay, number 2. Start by adding 13 to both sides. We get negative x squared equals 50. All right, here's the tricky part. You cannot have a negative x squared. It has to be positive x squared. So I'm going to divide both sides by negative 1. You could have multiplied by negative 1, same thing. Negative divided by a negative is a positive. So I have x squared equals negative 50. At this point, x squared is by itself, so I'm going to take the square root of both sides. Here I'm going to rewrite my problem up here, so I have a little more room. Square root of x squared is x equals plus or minus the square root of negative 50. Here I'm going to break this down. So I know negative 1 times 50 will give me negative 50, but I'm going to break down 50 to its prime factors. Again, I'm using a factor tree. What times what is 50? Well, I know I have 5 times 10. 5 is prime, so I just circle it because I know that's going to be part of what I multiply. 10 is 5 times 2, and those are prime. So I broke it down to my prime factors. You could have broken it down to 25 times 2, and 25 is 5 times 5, so you'll still get the same prime factors. So I'm just going to write it out. I have negative 1 times 2 times 5 times 5, and if I remultiply that, well, it gives me negative 50. All right, so I have to look at what can come out. Square root of negative 1 comes out as I. I have a 5 times 5, which means a 5 can come out. So I'm left with x equals plus or minus 5i square roots of 2, square root of 2, because that 2 has to stay underneath. It doesn't have a buddy to come out with. So again, this is read as x equals 5i square root of 2 and x equals negative 5i square root of 2. All right, number 3. You have to get rid of this negative 3 that is multiplied by our x plus 2 squared, because you have to get that squared part all by itself. I'm going to divide both sides by negative 3. So I have x plus 2 squared equals negative 20. At this point, I'm going to take the square root of both sides. So I have x plus 2 is equal to plus or minus square root of negative 20. All right, I want to break this down, see what it equals. X plus 2 equals, all right, we can break down 20 to 2 times 10, and 10 is 2 times 5. So this is plus or minus square root. That negative 1 is negative 1 times that negative part. Now 20 broke down to 2 times 2 times 5. Again, if I remultiply that together, I will get negative 20. So I'm going to bring stuff out. Square root of negative 1 is I, and 2 times 2, I can bring a 2 out anytime it's buddied up. So I have x plus 2 equals plus or minus, I have a 2i that came out, the square root of 5 that's still there. All right. Like the one before where I had an x minus 1 equals plus or minus 5, this one didn't have that I term, so I could actually simplify it to real numbers. But down here we have the I term, so it's not going to simplify to a real number. You're still going to have imaginary numbers, the complex numbers there. So here, to get x by itself, I'm going to subtract 2 from both sides. I'm going to put that minus 2 in front of my complex number here. So I have x equals, remember minus 2 is just negative 2. And then I have plus or minus 2i times square root of 5. And that is my answer. So if you put plus or minus 2i times the square root of 5 minus 2, go ahead and just get in the habit of putting that in the front. And the last one, right, this you have to move everything but that x minus 9 squared over to the right. So start by subtracting 1 from both sides. So we have 16 times x minus 9 squared equals negative 1. Divide both sides by 16. And I have x minus 9 squared equals negative 1 over 16. At this point, we can take the square root of both sides. So I have x minus 9 equals plus or minus square root of negative 1 over square root of 16. Again, when you have the fraction and you took the square root of the whole thing, take the square root of the top, square root of the bottom. So I have x minus 9 equals plus or minus square root of negative 1 is I over square root of 16 is 4. Well, I over 4, well, think of it as there's 1 I over 4, and 1 over 4 is 1/4. So this is the same thing as x minus 9 equals plus or minus 1/4 I. That's the exact same thing, and it makes a little more sense when you have the 1/4 times I. Going to rewrite my problem so you can see all the steps. X minus 9 equals plus or minus 1/4 I. Okay. At this point, I need to add 9 to both sides. So I have x equals, okay, this is my answer. Remember in the one before I said put that number in front of your I term. So we have a positive 9 plus or minus 1/4 I. And that is how you want to write your answer. All right, hopefully you were able to solve the equations, quadratic equations, by finding the square root.